Okay, hello. Well, let me know if you can hear my voice. Hmm. Well, maybe this is not working, I'm not sure. Well, hopefully, this is going okay. I'm gonna start this live stream and let me know if it's going to be some problem. If you cannot hear anything, then maybe let me know in the chat, or maybe I should check the voice myself. How do I do that? Okay, well, I think it's working, so I'll just get started. Okay, so this is a Houdini Algorithmic Live 152nd episode. This is the topic for today is to create a procedural aerial overpass, which is more like an expressway you see in many countries, like this one. So the initial inspiration is to create these complex aerial expressway or overpass procedurally somehow, something like these, which has the tons of like complex connections between roads. So what I came up with is to, first of all, for the curve, for the network itself, in this setup, I'm doing it manually by using curve. Specifically using polyline to create a simple network. So I have the first initial state is to create a bunch of curves as a road using like snapping to connect some of the points together where you want to connect the road. Then using some method to smoothen out the road to make it look a bit more like a road. Then later I am applying some thickness to each of the line. In this case, I'm just putting the thickness randomly, but you could also manually set up the width of each road, then make it as a highway like these in the end. Plus there's some columns for each areas. And what's good about these setup is that you could add additional curve right here on the initial step. I'll try. So let's say I want to connect some road to these connections right here from the ground and possibly reeve the road somewhere around here. And it will somehow smoothen out the connections if you if you need more smoothness, then you might also want to change some heights of each points of the curve to be able to control the height. Just gotta press this one, click here, move this up a little bit. So you have some decent connections to the road. Okay, so I'm just gonna show you how you can create a setup such as like these using Houdini, which is not that hard to do, I believe. Yeah. The key point is how you could connect the intersections to one road, how you can connect different roads together as intersections, and that's pretty much it. Okay, so let's do this from scratch. Okay, so first thing first, what I'm gonna do is to create some initial curve for testing. Let's do that. Let me first save the file to today's folder. I mean, there are a bunch of expressway tutorial for Houdini available in, I think, in YouTube and all the other places, but the method that I'm using here is kind of a unique in a way. Not sure if it's usable for gaming or any other like platform, but just as a curiosity, you might be interested in how I created. Okay, let's just try this. Now, I'm going to first create a curve node as a polyline, then create some random road network using a polyline. Later I'm going to smooth it out to make it more like a road. But for now, hard curve is fine. So click the show handle and just draw some lines randomly. And possibly it will be great if you have some height and has some connections, so let's also create a bunch of additional curves, then try to connect these curves together. Okay, let's just test with these simple setup and maybe a little more which have a loop. So something like that, and I don't know, connect it here probably. Okay, let's also move this point to here. Okay, so let's also set some height for each of those points randomly. Okay. So this part is not much of a procedural setup, but it's fine. I'm kind of ignoring the scale right now, so probably I might need to scale the whole stuff a little bit more later, but for now I'll just go with these. So trying to create some sorts of tunnel-like shape. Going underneath some of the road to create some complexity. Okay, well, let's just try with these, shall we? And I don't know, let me just write on the chat if anybody can hear me. Right, so next step is to make this curve smooth. Right, so okay, thank you for the reply. So in order to make this smoothen out, the easiest way you could do is to use obviously a smooth node as well as resample node, and that is also good, but I am going to avoid using it directly because I'll show you why. So if I use resample as well as some option like subdivision curve, it's not that bad, but those connections where you have a where you have an intersection between different rows, it's a bit too curvy for a road connections, I believe. Okay, what I wanted to make sure is to have as much as straight line as much as possible, and then turn when it's being connected to the other road when you have a branches. So to be able to get that kind of smoothness to this road, I am going to apply some customizable smoothness functions to this. Okay, so instead of using a subdivision curve, I'm going to make it as a straight edges divisions for now, which gives you a bunch of points by using resample node at this point. And what's more, I might also want to use a fuse node beforehand so that connected point will be fused somehow, so that it will have only single points on each connections. And then on the resample node, I am going to also check, since if you look at these points, you see that one of the curve is dividing in different steps. So what I mean is that the point right here and the point right here belongs to different curves. One of the points belongs to this curve, one of the points belongs to this curve, but I actually want all the points to be on the same position. So in order to do that, I am going to enable resample by polygon edge, so that each edge will be resampled in the same manner, so that the point will be the divided points for this curve and this curve is on the same position. Okay, which will be useful for the later process. Now the next thing I would like to do is to smoothen out the curve, but more iteratively, slowly smoothing the curve by trying to preserve the straightness of the current points as much as possible. So, and in order to do that, what I am going to use is, first of all, a small step of smoothness. So by using this, a little bit of smoothness being applied to the polyline, like these. Now the next step I would like to do is to, if the point, like these points are close enough to each other, I want to like fuse these points in one positions, maybe on the average positions. Like if the points between this one and this one is close enough, I want to make the point position of each point to be on the middle of these two, which is the average point positions. Okay. And continue doing that will enable you to preserve the straightness of the curve as much as possible, but making the overall smoothness going smoother when there are no intersections. So let's try that. So I'm going to use a point wrangle for that. And since I want to do this iteratively, I also want to place this inside a feedback loop or in the solver to make it possible to iteratively, recursively smoothen out using the same method, the same algorithm. Yeah, I will keep the video as a on-demand video so that anybody can watch it later, just like other live streams. Okay, so let's do this. So for the point wrangle, first of all, what I would like to do is to, for each point I want to search for the closest point, the near points with some threshold, like using some distance to search for the closest points. So I'm going to use near points function with some distance threshold. Now this threshold could be related to how much you have done with the resample node. Like currently the resample is being done 0.1, so you could, I guess, make it close to this value. Okay, so let's copy this value here and go back to, maybe this is a bit too large, so let's make it 0.2 for now, and let's copy this, and let's, first of all, let's have that informations right here as a parameter. Then I'm going to use this the parameter as a multiplier to this resample length. So let's say 0.5. I'm going to multiply this 0.5 multiplier by this resample length to get the final length. So if it's 0.2, then 0.2 multiplied by 0.5 will be equal to 0.1. So the threshold distance will be 0.1. Now, next step is to see if there are more than 2 points on this array. For example, this is where you have 2 points. So if you have more than 2 points, let's try to get the average. Now I might also want to have some testing positions where you have 3 curves being intersected for testing. So let's also create another curve in order to be able to have additional like 3 intersections on this part right here. So I'll just create this randomly. Let's have some lines here and just go straight like this. Okay. And I might want to move the endpoint of this point to here. Okay. Okay, procedural CD videos. Most welcome. Okay, I would also want to create some videos about procedural CDs as well, either from scratch or using some map data. Could be interesting. As I was in architectural, I was on the architectural study as well, so yeah, let's do with these. Go back to the point wrangle. Let's give a conditions. If the length of the new points, the number of new points is more than 2 and more than 1, meaning if it's equal or more than 2, then first of all, try to get the current positions. Then loop through all the points inside the new points array. So the first point of this new point is going to be yourself at P. So you might wanna skip that because it's nonsense to compare with yourself. So what I'll do, starts from 1, make a loop. So if you say 0, then the first array will be picked, which is yourself, so you don't really need to compare with that one. So that's why I'm starting from 1. Now we'll get the new point number. Let's also get the primitive number as well. Do I need that? Maybe not. And oh yeah, I do. I actually do need that, I think. Yes. Let's also get the primitive number from this new point number, which you can do that by using point prims. Just get the first one. Now you also want to get the primitive number for the current point. So let's do that. Okay, so what I want to do next is to well, one thing that I want to make sure is that I don't fuse the points when the direction is not aligned. Okay, direction of this point is not aligned. What I mean is that if the point is crossing, like going this way, which is not aligned with this road, in those cases I don't really want to fuse even if the point is close to each other. So I want to make a conditions to skip those points which are going in the different direction. Okay, so to do that, I kind of need to get the tangent tangent vector of each point in order to check if the direction of those rows are on the same directions or not. So beforehand, I am going to apply some orientation along curve, which gives you a tangent vector as an n attribute. These, so we can use this and to check if the direction is on the same this directions or not. Okay, so let's get that informations. So vector and norm is point npt, and if the current point position is point. Okay. Now first thing first, additional information. If the point that I found, the current point and the new point belongs to the same curve, same primitive, I kind of want to skip it. If it belongs to the same road, I don't really want to fuse it, so let's skip that. So if prim is not equal to the near point primitive, as well as if the dot product of the current tangent vector as well as the near point tangent vectors is on the same directions. Now I think I want to use the absolute, because could the negative value, -1 and +1, could also mean it's on the same directions. So just want to make absolute. Then if it's close enough to 1, like more of 0.95, which is really close to 1, which means it's pretty much along the same direction, then you might want to make some average positions. In this case, I have started from a C-pos, so I'm going to add additional point position, the end position right here, and after leaving the loop, I'm going to divide the point position by the number of points that I have added. So currently I have 1 point positions being added on the C-pos, so I'm going to start the count by 1. Then each time I add additional point position to C-pos, I'm going to also count it up by 1. Then in the end, after you leave the loop, divide it by count so that you can get an average position of these 3 points. Okay, now that you got the average point positions, you might also want to make it sure that this is float number. Since this is vector, I might not need to convert this into float, but just in case, in the end, I'm going to update the current point position to average point positions. Now then, you could see that all the point which is close enough has been merged together. Now if you change this to change its threshold, you see some changes. If it's too small, it's not going to merge. If it's too big, you're going to merge the other points as well. So let's keep it 0.5 for now. Okay, well, thank you for the comments, everybody. So that's the first step, and let's name this custom fuse or custom snap. Now what I want to do is to continuously use this method over time recursively, so that you are slowly smoothing out the curve as well as slowly snapping the points to make sure that the points is going to stay the straight lines, try to preserve as much as possible, as well as making the single curve be more smoother. So to do that, I could either use solver or for each recursive loop. Well, let's try with the solver first, then I'm gonna choose for each later, because you don't really want to use timeline to get the final result. So, but just for to see how it works, solver is good in terms of seeing the results. So let's bring up these 3 nodes into the loop, into the solver, connect it like this, What's this error? Okay, so I am missing a link. I have to recopy the parameter, paste it. Okay, now let's check how it's gonna become. Now if I play it, you see that the smoothness is smoother on these single line, but at these areas it's try to keep the smooth straight line as much as possible, and try to keep these, like, how do I say, the branch and point be angled as much as possible. Now if you compare this with just the regular smoothness, maybe using something like attribute blur, you'll see some differences. You see that if you just use a attribute blur or smooth node just as it is, you'll get a result something like this, where all the points, it's going to like have split it far away. On the other hand, in this case, you could preserve the point where it's already been fit together on the same positions and make the other place smoother. Now, what if I do the fuse to do attribute blur? In this case, it is a little bit better than before, but as you can see, the way it's smoothing out is not really preferable compared to how it created the network like these. This looks more like a road-like network. This is a bit too like direct, like bending or direct rotation. Not really smooth. Doesn't really look smooth where it connects to the other road. I guess this is just my opinion, but that's what I thought, so this is what I'm going to use for this setup. I mean, if you find this one better, then you could always go with these as well, which is much easier. Okay, so that's the reason why I'm using it, and I don't really want to do this inside a solver, so because each time I want to get the result, I have to play the timeline if I use solver. So instead, I'm going to use for each loop to define how many loops that I'm going to use to smoothen out the curve. So in order to use this, you have to set feedback each iteration. Okay, sorry for the low volume. My microphone is a bit low sensitive. How's this? I'm trying to place my mouth close to the mic. Okay, so for each loop, set it to feedback loop. Set the iterations to feedback each iterations. And set this method to fetch feedback. Then paste the node to inside this for each loop. Okay, so now I have to recopy the resample parameter again, since this is on the same network. Okay, so now it should work pretty much the same as for each loop. I mean the solver, but you just need to specify how many iterations you want to apply the same smoothness and snapping function. Now let's see, maybe 100 times is enough. I mean, you could always change this by yourself. Now, if you need more straightness right here, you could, I mean, always go back to right here. I mean, this already has some curveness right here, so you might want to just increase the length here or make this resample divisions a bit smaller, which will make all the curve smoothness a bit slower, so might be the same. Might get the same. I mean, if you change the resolutions for each curve in a different value, you might be able to control these parts smoothness as well. Now, for now, I'll just go with the same setup. Just set this to 0.2. Okay. Let's say I'm gonna go with this. Okay. Now, next step. Since I now have a smooth curve, it's time for me to create some width, the thickness to each of the curve. Now, I saw many like method which is shown on the internet, and a lot of people are using different method. The method that I'm going to use is to use a VDV, a volume-based modeling. So, and for some people it might not be preferable because VDV is a bit hard to predict the final resolutions, and you're also going to get high res results in the end, so that might not be preferable for some people. So I understood that, but in order for me to have some versatile result, I needed to use it. Well, let's see how I did it. Okay, so first of all, what I'm going to do, again, I'm going to fuse the curve points to 1. Then again, I'm also going to use another resample node. In this case, I'm going to add a lot of points to to each of the edge. Now I might also want to check this resample by polygon edge again, and what I want to do, copy the lengths that I have used here for the first resample node then multiply by 0.1 so that I'll have more points on each edge. Okay, and maybe using some smoothness options like 3 polygon as options to subdivision curve to have a little bit of smoothness for each edges. Okay, now the next step that I want to do is to create some pipe shape to each of the point with different scale, different width. Now how do I define the width? Now for the sample project that I created, I just set the width randomly, but you could also manually apply the width. Like for example, for this curve, I might want to make it the thickest road. For this road, maybe thinnest, and so on. It's up to you how you decide it, but let's just try with some randomness or based on some properties like the current road length. Now let's check the parameter for each primitive, see how it's been diverged. Okay, so we have 4 types of curves with different lengths, so let's see if we could set the p-scale, I mean the width, based on these parameter. Okay, so let's do that by, for the width, I'm going to use a p-scale attribute which could be used with a VDB So I'm going to, and I have to kind of apply the p-scale to each point that I'm going to use point wrangle. Then in order to access the lengths, first of all I need to access the primitive number for each point. So let's get the primitive number first. Let's get the perimeter. Alright, then use that perimeter to set some width. So let's say the longer the road is, the width is bigger, the wider. And you might want to make the width of the road like multiplication of some single like road lengths. So let's say the single road length can be defined by yourself. I don't know what will be the best value for now, but let's say 0.2. And then let's get the, I don't know, the minimum and maximum of this parameter, shall we? So that the minimum will be using the single like road width, and the maximum will be, I don't know, maybe 4 or 3. So to do that, I'm going to get the minimum and the maximum of the perimeter using attribute promote So I'm going to promote from primitive to detail the maximum of the perimeter. Let's change the name to max peri. I am probably missing, okay. And do the same for the minimum. Change this to minimum, change the name to minimum min_peri. Okay, let's check the detail attribute. So I have the minimum length and the maximum length. So let's bring this up inside this point wrangle, accessing to a detail, get the max length as well. Then try to create some integer value by fitting or remapping the current length of the road, which is in between minimum length to maximum length, then 1 to 4, and make it as a round integer value. As a result, you get the value in between 1 to 4 by converting perimeter. Then in the end, I'm going to just multiply the scale value, scale integer, by a single road length. Okay, and let's see what happens. So I have just created the road width, and let's try creating some pipe. Ooh, am I missing something? Okay, yes. Sorry, thank you for the comments. I have misspelled it. You're correct, yes. Hopefully I am having a correct p scale. Yep. So it's a multiplication of 0.2 from 0.2 to 0.8. Okay, now I'm going to use a BDV from particles to create a pipe shape by these points. Now I can see that the width is a bit too big. So let's fix this up. Maybe 0.1. Still big, and I do see some intersections here. This might going to be some problem, but let's see if this is gonna work. And maybe the VDB resolution is not good, high enough, so let's go back to resample node right here, copy this parameter, go back to the VDB from particles and paste it right here, which will give you some smooth result. Maybe this is a bit too high. Multiply by 2 is enough. It's up to you. Maybe 1.5. Okay. Now I might not like these intersections, but let's see if I can solve it. It's better if you don't have these intersections, so if you want to avoid it, you could make this smaller. Okay. In the end, I want to make those pipes flat with the up vector. I want to make a flat plane on those pipe. So in order to do that, I might not want to have intersections like these, but I'll try this later. For now, for safety, let's avoid using that. So let's go with these. Okay. So let's save it, and after I have created the VDB, I kind of want to reconvert it into a polygon so that I can create a flat face in the end. So let's do that at this point. I'm going to use convert VDB. Okay, convert it into polygon. Right. Now, after I have converted it into the polygon, what I want to do next is to make the face of the road to be flat. Currently it's just a sphere, the circle pipe. The cross sections of this pipe is just a circle, but I want to make it a flat plane. So how do I do that? Actually there's a guideline, which is this one, which is the guide for the road. So what I'm going to do is to for each point from this pipe geometry, I'm going to search for the closest point, for example like this point, to the curve, the road curve, and just copy the height of the closest point positions on this curve road, and use that height to apply the height to each of the point found on the pipe, which should give you some flat surface all over the world, all over the place. You might have some issues somewhere around here on the connections, but let's see what would happen. So for each point on the primitive, on the pipe, I'm going to search for the closest point positions. In order to do that, maybe you could just use min-pos function, which is the easiest. So min-pos, look for the second input, which is the curve. Check with the current point position. Now, after this, just get the y value, the height value, then apply it to the current point y value. Let's see what happens. And now everything became flat. Looked more like a road. Now I do see some issues here and there. That is because for those connections you might want to make these positions as much as flat as possible. Try not to make these too steep on the connections, but try to make it a flat on initial connections, then gradually make it a steep curve. So to avoid it, go back to where I'm creating the curve. Okay, somewhere around here, and what I could do, add some points in between the connections, somewhere around here. Oops, not the new one. Let's do this again. Okay, so this has been added. Let's add additional one somewhere around here. Okay. Now let's change the tool to move. Pick this one. Move this a little bit upward so that the initial connections of two road will be flatter. Let's remove the snapping and okay, well, you might want to add additional points to this. Okay, so for this one as well, let's move this underneath, going downward. Let's select here. And probably I might need to make this inner points again. To control the curve. Okay, so becomes a little bit better right here. And over here. Now, although the angle is like 45 degrees and that's too much for a car, so it's not really realistic. But just this is just a testing. Just to test how it works. Might want to move this to. Move this a little bit to this direction. Okay, so the the goal is to make the surface as flat as possible. Okay. Okay, well, I'll go with these for now, and you could. I'm also going to apply some smoothness to these faces as well later, so to avoid some jaggy face like these. Okay. Now, the next step that I want to do. Currently, I have just moved the point to a curve position. I just moved the point height. For each pipe to a curve height, meaning I still have a backside and the front side of the pipe. Now I don't really need a backside anymore. You see the buffering happening right there and right there. So just want to delete the backside and just keep the front side after this process. So to do that, I am going to, first of all, calculate the normal for each face primitive. Then based on the primitive directions, I'm going to delete that face. You could let's say use a group node. Just get the backside, the bottom side group by using keep by normal. Set this to -1 for y. Set this to, I don't know, 90 degrees. And you can pick all the backside, the bottom side faces like these. Then delete that face. Okay, now you're left with just the front side of the upside plane. Okay. Now let's recalculate the normal. And the next thing I'd like to do is to make the face of this plane cleaner, because right now the resolution is a bit too high and some of the parts is not really clean, like these connection positions. So let's try to make these part clean. Okay, so to do that, first of all, I'm going to apply some remesh to this one. And apply some lengths, target lengths to whatever resolutions you want. Let's go with 0.75, something like this. Okay. And next, I also want to smooth out the outline. For example, like these one is a bit weird as road connections. You don't really want to have this pointy connections like this, so I want to make it smoother as much as possible, and based on those smoothness might also want to make the face smoother as well. So to do that, and what's happening here? Well, let's go back to where I have now this thing. Okay. Anyway, let's go back to here after I have remeshed. Now these jaggy outline is also not so clean, so I want to also fix these parts as well. So let's do that. Now to do that, the step that I'm going to create, the step that I'm going to do is to first of all get the outline of this current mesh and smooth just the outline and move the point of this remesh regarding to the smoothed outline. Okay, so to do that, first of all, I'm gonna make sure nothing is just remove all the unnecessary points by using fuse. You could also use clean, and let's also use divide to just get the outline by removing the shared edges, and then using polypath will give you just the outline as a curve. Okay, so after getting the outline, you can use a node like smooth to smoothen out these outline curve pretty easily. So use smooth, and by using smoothness, you see you're going to have some fix on these areas by increasing iterations. Let's make this 100. And you are no longer seeing these jaggy edges as well. Okay, is it enough? I still might want to fix these parts a little bit more. Let's check the edges. Okay. Okay, maybe let's go with these. I mean, if you try to make the target size of the mesh higher, it's such a bit more easier to smooth. So maybe that's the way to go. Looks still okay. Okay, so let's say I want to use this outline as a final result instead of this outline. Okay, now to do that, I'm going to move the current mesh edge point position to the corresponding point position which has been smoothed out. And to do that, I need to refer to the curve which hasn't smoothed out yet, then also refer to the smoothed out curve as well. Then going inside the point wrangle. So the first input is just this mesh, okay? And what I want to do is to search for each point on the border which corresponds with these outline point positions. I can find it out by just checking the closest point and check the distance between those 2 points, and if the distance is close to 0, then that means the point on this mesh is on the border, and if that's on the border, then what I want to do is to just update the point position based on the smoothed point position using the same point number from the second input. So let's look for the closest point on the second input, get the point position, and check the distance between the current point position on the surface and the border curve, which hasn't smoothed out yet. And if the distance is close to 0, which means it's on the border, you might want to get the corresponding target point position from the third input. Then update the current mesh's point position to this target point position. As a result, you see that the edge of the outline of the surface has been fixed. If you bypass this one, you see the difference. Okay. Now after this, you could apply additional surface smoothness like attribute blur to smoothen out the road mesh itself. Like that. Makes you a bit more smoother connections. Now this might not be really realistic in terms of the real world, but if you look from far away, it might be okay. As I said, I mean, if you want to have more concrete method, maybe this is not a way because it's using BDB. But anyway, looks good. And you might also want to update the normal map again to clean it up. And everything looks a bit better. Okay. Now that I have the base face, it's pretty easy for from this setup. This is the kind of a core logic of this setup. After this, you just need to just make some thickness to the road, give some fences and columns, and that's pretty much it. Okay. So let's do that. First of all, some thickness. The easiest way, maybe I can just make it reversed. so that face is facing bottom. Then using a node like lavs thickening to give some thickness. Now, what's wrong with these? It's not smooth. Okay, one thing I might want to do after I have smoothed the outline. After I have smoothed the outline, somewhere around here or somewhere around here, there's a chance that some points are being on the same positions in the end, so let's make sure that two closed points are being fused. And for the snap distance, I might want to use a parameter related to this remesh value. So let's copy this and paste it to here. Maybe multiply by 0.5 or something. And that really didn't give a clean result. Maybe I want to set the output position to least point number. It's not really nice yet. Maybe beforehand? No, maybe not. Maybe right here I might want to increase the target size. Okay, so this is better. Okay, now let's go back to see if I'm getting a nice result. So still see some jiggering. Why is this? Well, maybe it's related to the normal directions. So if I make this the point, doesn't really make difference. Okay, maybe the thickness is a bit too thick. I mean, more height you get, more height you use, more different result you get. I mean, some random result you get. So let's make this thickness small enough. I don't know, 0.02, something like that. Okay, so this looks better. Okay, not bad. I mean, let's see if I could use poly extrude instead. See what we get here. Using the same parameter, 0.02 for distance. Okay, much dirty. Nope. Still some errors here, so could better using thicken, I guess. Okay, that's that. Now let's also create some fences for the highway. To do that, you just need to get the outline and then extrude it on Y directions. I mean, if you need more fancy fences, you could do more, but I just create the simplest one. Okay, so to do that, let's go back to where I was creating a outline, which is somewhere around here. Okay, this one. So maybe I can just maybe I can just use this one. So I am going to apply a normal attribute to each of the point of this curve. Let's go variable n, vector value, set the y value to 1. Okay, and use that value to extrude it upward using poly extrude. Set it to point normal, existing, and set the distance. Okay, now that's pretty easy, but one thing I want to do is to set some thickness to the wall. Now this one is facing all the same, but some cases there is a chance that the a direction of the face is facing in different ways. Let's see if I can make that situations. How do I do that? Let's try making some of the curve reversed. Does it changes? Nope. Not really. Currently every polygon is being connected as one, so maybe it's not a big problem here, but let's create some looping connections. Let's see, where should I sorry. Where can I create a loops? Let's say I want to connect the curve from this point to somewhere like this point, like connecting like this. In this case, I could try connecting like these, or maybe connecting like a circle. Might be interesting. So let's try that, so that I have some loops here. Okay, so to do that, let's create additional curve, and let's start from here. And connect it like this. Okay. Now go back to the selection mode. Make this length a little bit longer. And adjust the curve a little bit. Like that. Okay, let's see the result. So the face, starting with oops. Now I see I do have some problem here. Let's see why. So I have this curve fused. Should have created the width. Okay, the connection, made it flat, remeshed it, outline being smoothed. Oop. I was missing, I kind of forgot to I kind of disconnected somehow from this smooth outline. That was the reason. Okay, now everything looks good. Okay, so looks okay. Now let's go back to the fence and see if I can have, well, not a big problem here. Everything is facing in the same manner. Okay, well in that case that's fine. I mean, it's easier. But let's say let's make some difficult situations, like for example, let's go selecting some of those. How do I select it? It's kind of funny how why it's not being selected. Where is it? I think I'm missing something. I want to just select all the connected faces together by double clicking it, but it doesn't work. Maybe I need some options right here, but I don't really know what I need to do. Okay, well, let's say how do I can't connect, I can't select. Let me just test with the simple geometry and see what I'm doing wrong. Just wanna drag and drop and select the face. And I don't see the selection lasso or anything. Maybe that's the problem with my Houdini. It's actually selecting. I cannot just see it. Disable secure selection. Is this one? Still the same. Not really sure why. Huh. Can I try reopening this file just to see if it's gonna fix? Nope. Not really. Well, I could select on my samples where I've created, so maybe I have some options which I don't really need. So if I'm by looking at the samples that I have, I do have the secure selections on, and this one's on, mesh is on, selection node on. Somehow I don't see the selection. Let's try bringing this. Well, if I move this to a different display, and now I see the selection, so I guess it's a problem with my display that I'm streaming. So in that case, now I see it. What was the reason? I don't really get it. Press enter. Maybe that was the reason. Okay, now I think it now works. Sorry for the hassle. So let's say again, maybe this is the issue. This thing, oops. What I'm gonna do, I am just going to create the null node, connect it to poly extrude, and there, hopefully I'll be able to select. Nope. Let's try bringing this to this different display, going back to right here. Somehow my selection box is kind of having a weird operation. Not working pretty well, but just wanted to test so that some of the faces might be facing in different directions, like these, by using reverse. Oops. So in some cases, there is a chance that some of the face, the normal direction is facing the different ways. So in those cases, if you use a node like labs picking, going to have some problem where you are having a flip. Okay, so that's what I want to fix generally, procedurally. So I actually didn't have that problem, but in the sample that I made previously, I had this problem. So what I want to do is to start from this setup, having some errors on the normal directions for each faces, and I want to fix those face directions to have a consistent wall thickness all over the places. So I'm gonna use this as a test sample. Now going back to a face. Now this face surface could be used as a test geometry, a guide geometry, to actually fix the normal direction of each of these faces. Now what I could think of is to check if the normal direction of the wall is correct or not by, let's say, move the center point position of the face to a normal direction of the current face. In this case, the white face is the normal direction. If you click this one, you see the normal direction for each face. So if you move the point position to that normal direction, if you look at the bottom, you are not going to see any face there. But if you move it to the other directions, you're going to see the face underneath with some within the height of the fence. Okay. So in that case, maybe you could reverse the face normal to other directions to make it sure that it always align in the same directions. The face always align in the same directions. So let's say I want to have this white face facing inward, or maybe outward. So I want to make sure that these gray area will be placed inward, and white area will be placed outward. So you always get the white faces on the outer side. Okay, so to do that, I'm going to use a step just as I explained. First, create the normal for the faces and get the center point position of the each face, and then move it toward the normal directions and check the intersection between the guide face right here that I have. So connect this to a second input, and first of all get the center point position. Okay, which is at P, and move this point position to a normal directions by a little bit, just a small amount. Then try to create an intersection analysis between the second input, which is the floor face of the road, on the negative directions of the road, but you also want to specify the height of the intersection ray, which should be close to a fence height, because you're using the center point position of the fence. So let's get that height set copied from this distance, which is the height of the fence. And you also need some additional variable like intersected point position, but you're not going to use it, but you need it in order to use intersect function. Now let's check if the intersection is negative or not. If it's positive, that means you are getting the intersections, meaning the white face is on the inward of the road, which is not a case that I want. So in this case, I want to make the face flipped. So to do that, I'm going to apply a group to those faces in order to flip. Then for those faces that needs to be flipped, I'm going to use a reverse and filter with the flip. Now as a result, hopefully everything will be flipped so that the white face is facing outward, the gray face is inward. Okay, so it should work even without the testing. Let's go back to the original test case. So this was the issue right here. These faces doesn't need to be reversed, but these faces needs to be flipped. These faces needs to be flipped, and as a result, everything is on the right orientation. Okay, so that seems to work. Now you can kind of remove the test case, just in case. I'll keep it. Okay. Now after this, you can just apply thickness to the wall, fence wall, with some small thickness, and use it as a fence. Now let's merge these two together. Okay, let's have some color to the floor, some grayish color. Okay, so far so good. Next I'm also going to create some column, and I'll finish this live. So for the column, it's pretty easy. I just need to create some, like, I don't know, square face column with some even steps, and if there are rows underneath, then you might want to skip grid and column and some of the parts. So that's the basic rule and not that hard to do. So to do that, you need a original curve, which curve should I use before creating the pipes? So somewhere around here, yes. And you also might want to use the thickness, the width of the pipe as an information to define the width of the column. So maybe somewhere around here where you are setting the P scale. Okay, so this is where I can use to create the column. Now next, where should I start? Maybe I can just go with these, but the problem is the point number is too much for this one, as you can see here. So instead of using this curve as a base for the column, I'll go back to where we have small number of points, somewhere around here. Or you could reduce the number of points. some points around, I don't know, maybe let's try using this one and see if I can solve it. So okay, well, maybe might not be a good idea. So let me see how I can, which lines should I use it? Okay, the thing is, multiple road is using the same, is placed on the same line sometimes. For example, this part, it has 3 types of road combined right here as a curve, and each line has different width, and what I want to get is the highest width information among the 3 curves intersected right here. So to do that, you could still use this one as a guide. Let's try. So using point wrangle, and for each point, want to look for the closest point, the nearest point on each point, and then check the p scale for each point and get the highest one and set it as a width of the for the column. So use a near points, and the tricky thing is the range for the near points search. Since this is pretty dense, I kind of need to use the similar parameters, which is this one, to search for the closest points. So I'm going to copy this resample value here and paste it here, and probably multiply by 0.5 to have a search. And let's name this get highest p scale. So I'm going to loop through all the points. In this case, I'm just gonna include myself, I mean the point itself, and get the number, get the p scale, at this point number, and then just get the highest. Starting with -1, update the max p scale with using max function, just like that, and then update the current p scale to the max p scale, and hopefully the p scale right here will be the chosen the maximum one. And let's check. Okay, so previously you have multiple number of p scale available on this point, but then by using this one, I'm just having the highest p scale on the intersected points, and seem to work. Yeah. Okay, so look good. Now next step is to fuse the point, because I don't really need a multiple number of points on each point position, so just fuse it to remove the duplicate point, which reduces a bunch of points, and calculate, in order to align the square column along the curve, I need to have the tangent vector. So let's give a orientation along curve node to apply some tangent vector, in this case a n vector to each point. Let's check like that. Okay, then right now the number of points is a bit too much, as you can see, so let's also reduce the number of points. Now before doing that, the point has been fused, but actually you still have primitive, or this primitive and this primitive is individuals. Okay, I just need a single primitive available on these part where you have intersected lines. So to do that, by using something like convert line, will give you just a single line where you have merged points with the same line distance. Then connect each line again using polypath, or reduce having multiple lines available on these part. Okay, so if you delete this part, you now have you no longer have a duplicated lines right here. Okay, so that's good. Then hopefully I am preserving the normal direction for each point. Yep, which is necessary. Now it's time I reduce the number of points, because if I try to place columns on each point, that's too much, obviously. So let's reduce the number of points by using resample. Define the lengths to whatever you want, like, and maybe 0.25, still a bit too much, maybe 0.6 or something. Okay, let's say these are the points that I want to place a column. Okay, and let's make sure that you still have a tangent vector available for each point, and looks good, and lots of p-scale, and looks good. Okay, so I have enough information. Let's create a point information on let's create some point information on each point to actually copy the column geometry. So I'm gonna create a column geometry like from a box, and try to copy this box to each point. Now currently this is a line in using normal and up vector as well as p-scale, but it's just a box like this. But in order to make it as a column, I need to kind of modify a point attribute of this resampled curve a little bit. So let's do that, shall we? So first of all, kind of want to create a column from this point to the ground floor, which is y equal to 0. So instead of using p-scale, I could use a vector scale to define a scale for each x, y, and z. So let's try doing that. And also for the box, I want to make the top part to be on the origin, so that I can place the box on each curve, so that the top face is going to be placed on the curve point position. So to do that, going back to the box, just make the center negative 0.5. Okay, so that the top face, center of the top face will be on the origin. Okay, now going back to a point wrangle. First thing I want to update is the V scale, the vector scale, and set a scale for x, y, and z. Now the y should be the height of the point, so and x and y, x could be the width, z could be the width, I'm not sure which one, so let's try with the x first. So for this one I'm going to use a p scale, and for the z, if you want to have a thin like column, let's try with the really small number. Okay, and if you have both p scale and v vector scale, both of them are going to be used. So after having a vector scale, I don't really need a p scale anymore, so let's delete that. Oh, can I delete it using the vex? Okay, remove attribute. 0 point p scale. So hopefully the p scale attribute's been deleted, but instead the vector scale has been created. Let's see what would happen. Okay, well, still some problems. You might also want to update the normal and the up vector now. The height seems fine. You just need to control the orientation for this one. So first of all, let's set up to 0, 1, 0. Okay, now looks better. And for the tangent vector value at n, you might want to make sure that the up vector value is 0. So meaning something like this, and normalize it. Okay, so that you could avoid a skewing. And now looks better. Let's try merging the road with the column and see how it looks. And yeah, looks pretty much like a column now. Now I do see some problems here where you have intersections when you have a road on the bottom position, so we need to fix that. But overall, looks fine. You do have some problem here as well, where it's kind of a going too much on a height. Now in this case, the easiest fix is just to increase the thickness of the floor, I guess, which is might not be a good solution, but it still works. And I realized that the fence wall is kind of intersecting with the wall, the floor, so maybe I could go back to the reverse, and instead of flipping this one, I could say the other way around. Okay, now this look better. So I just extruded on the outer direction. Okay, so let's try fixing the column position. which I can do it somewhere around here. Now, things you need to check is whether you have a face underneath from that point where you want to place the column. And the face is created somewhere around here, right? So using this as a guide, check the intersections going underneath. And if there are intersections when creating an array from those points underneath, then just skip creating that column. That's all. So let's move this downward a little bit, and let's create some additional point wrangle. Connecting the surface to the second input, and just check the intersections, shall we? So give a additional variables, use intersection function, intersect functions, looking at the second input, starting from the point position, and let's just move this a little bit downward because there's a chance that it touches the same floor. So move this downward a little bit. And the direction is negative, I don't know, really high value to y direction. And if you have intersections, meaning if the value is more than equal to 0, that means you do have intersections, then that column should not be created. And let's check. And there you go. The column has been removed. If you bypass this, you are having it. So I think it's working. Okay, so overall, I think everything has been worked as I wanted. And this is pretty much it. Okay, so this is pretty much it for the live stream that I wanted to show for today. Let me know if you have any comments, questions, or feedbacks. Anything, I'll try to answer. And meanwhile, I'm going to clean up this node network. Okay, so this is the important parameter for sure. Let's make it a blue. And there are several parameters that I could set up later. Are you using Unreal? Not much. Instead, I'm using Unity a lot. But sometimes I also use Unreal for some projects. But for my own project, mostly Unity. Yes. And sometimes related to Unreal, but UEFN, I also use those. And where was I? So let's see what kind of parameters that I can set. First of all, yeah, these resolutions. Okay, let's copy this. And the number of loops for smoothing. Okay, let's say from 0 to 1000. What else? diffuse, resample, measure, road width. This could be parameter, so single road width. You could parameterize these parts as well, I guess. So max road number, road multiplication, I guess. Max road, how do I call this? Max road is multiplier. Okay, the minimum should be 1. Okay, and this is kind of automatic. Delete, remesh. Okay, remesh size. Could be parameterized. What else? The height of the fence. Zero to 1, I guess, and this is smoothness for the surface, I guess. So this is for smoothness for the curve. So curve, outline curve, smoothness. And this is road smoothness. This one, let's make them all maximum to 1000. Okay. What else? The thickness of the fence. Let's make maximum to 1. 1.5. And the color. Okay, let's go to the column, and you have automatically calculated value, convert, polypass, resample. Yeah, this one. This is the column step lengths. Go, and it's pretty much automatic. So okay, so this is pretty much it, I guess. Now let's go back to a controller and try changing those parameters, see what we see a difference. Now if I change the smooth iterations to close to 0, you have more like a hard surfaced road, which is also interesting. You have a high smoothness, you get more curvy one. Just control based on those iterations. Single road width, you can control the how much is the single road. Now I can see some issues here. These issues are being created because of the BDB pipe is being, I don't know, merged. So that's a problem. If you want to avoid it, try not to make the width too big, or have some space between these road. Okay, what's this? Kind of getting some funny. Okay, and you could also increase the maximum height, well, maximum width multiplier. If it's equal to 1, then all the width it will be equal. And what's this? Okay, maybe that was too thin. Okay, and if you increase it, yeah, you can have some variations between the road width. I mean, the way you set up the width for each primitive, currently I'm just using the primitive length parameter, but there are, I mean, it's up to you. You could just set it customly by yourself. That's also fine and still works. Okay, and what else? Remesh size. It's just changing the resolutions. Not that important. Height, fence height. Yeah. Thickness. This is not a fence thickness, but this is the floor height. My mistake. I'll just copy this. Go back to where I was creating a fence thickness. Not this one, but this one. Okay, and I don't really need to change the floor thickness, so I'll delete it. Okay. Okay. What else? The outline curve smoothness. If it's 0, you have more jaggy outline. It's not really optimal. So you can raise this up to have some smoothness over curve. And for the surface as well, if it's 0, you have some nasty face like this. So if you want to have more cleaner face, you can just increase this. Alright. And column, if you want to control the density of the column, you could do like these. Doesn't really look like a column anymore, but what does it look like? More like I don't know, roller coaster something. Okay, so that's it. Hopefully you have learned something new here. And I think I am done with this. Okay, Sarhat, thank you for the comments. Thank you for the kind words. Looking forward to have you again, maybe next week. At around the same time. So let's just finish this live. As always, I'm going to keep the live stream recorded and you can always come back to watch. I am going to upload the file that I've created on the live way, and I'll paste the link to the video description of this live stream page so that you can come back later to download the file. And that's pretty much it. I also have a Patreon page, so if you are kind enough to support me, that's also great. Okay, that's it. Thank you very much for coming, and see you next week.